Hi, welcome to the course. Please don't skip this video because here I'm going to tell you what to expect from this course and how to take it. I designed this course not with the intention of giving you as much information as possible, but with the intention to keep you motivated so you can eventually learn Python and not give up like many students do. They start learning and they don't manage to build any program, so eventually they have to give up. In this course, I explain everything by referring to real examples. First, you are going to learn the basics of Python, and while I'll teach you the basics, we also look at some simple code examples, things like filtering a list of numbers, finding words in a piece of text, and so on. Then once you learn the basics, we focus on building real useful programs, which people can actually use. Indeed, I'll teach you how to make a desktop program with Python, and that program has a real friendly graphical user interface, where the user can input data into the program, your program processes the input, and the user presses buttons on the interface and they get back the output that you processed in your program, and you'll code that entire program in Python 3. I'll also show you how to make a web application with Python and even deploy that web app on a live server. So by the end of the course, you will have your own website, which you have built with Python. And building these two apps, so the desktop app and the web app, will give you an excellent insight of Python, and you'll be able to make more apps after completing the course. So this is the content of the course. You have videos, you have quizzes, you have exercises. The exercises can be solved directly on the Udemy interface. So you can just write the code in here and press on check solution to see if your code was correct. First, the exercises are simple, but they get more difficult as you progress through the course. In the beginning, we are going to use what I like to call it as a bare bone text editor. It's a very simple text editor, no distractions. We have advanced editors, but advanced editors let you autocorrect the code and fold the code and do things like that. But that's bad for a beginner. You don't want your text editor to automatically do some things on your code. Programming is going to seem like a black box for you if your editor does part of the job. So first we use a plain text editor where you have to do all the coding and you have to fix the errors that you make on your code. And later, once you have become better with Python, we switch to an advanced text editor. I'll cover how to set that up, and so one step at a time. The plain text editor is indeed a cloud-based solution that we use now. In the first part of the course, you can access that text editor from your browser, which is very cool, so you can run Python from your browser. This also allows you to code in Python from your mobile phone, since all you need is the browser. So that was a short introduction about the course. Have fun with Python! Hi there, and thanks again for choosing to take this course. I promise you will learn a lot if you are motivated to keep going. Alright, so now you're going to start learning Python basics right away, starting from this lecture. And specifically in this lecture, you're going to write your first Python program. Note that this is not one of the 10 applications that the course promises to build. This is just a simple program to get you started with how to write and run Python code. So let's begin. It doesn't matter whether you have Python installed or not in your computer, because I'm going to show you how you can gain access to a Linux computer and write Python programs from that Linux computer. So if you don't know, Linux is an operating system, by the way, just like Windows and Mac operating systems. And Linux is a preferred operating system by programmers due to its powerful command line utility that allows you to interact with the computer using commands as opposed to doing mouse clicks and dragging files and so on. Even Windows and Mac have the command line utility, but that of Linux is much more powerful, and Linux also has other features that are good for programming. So besides learning Python, you're also going to learn how to use Linux, which every programmer should know how to use. Okay, so I'm not going to send you a computer to your home address, okay, but I'm going to show you how you can gain access to the computer, how you can use the computer from your internet browser. And that's entirely for free. So there's a service there called pythonanywhere.com. So please visit pythonanywhere.com. And here you'll be able to host, run and code Python in the cloud. And they have a free plan, which doesn't give you a powerful computer, but it's good to start off with that plan. So I've tried it and it will satisfy all your needs for learning Python. If your applications that you're going to build have lots of visitors and lots of processing, then you may opt in for paid plans. But that's going to happen later when you get more experience and you start writing real programs. Okay, so let's go ahead and sign up for an account here. So we want to create a beginner account. If the website looks different on your end, don't worry, because Python Anywhere they change the layout sometimes, but basically the things will work the same. Okay, so here you want to put a username, an email, and a password for your account. Then click on I agree the terms and conditions, and then click on register. And that's it. If you want to see the tour, go ahead and go click next. I'm going to end the tour and show you around a little bit. And I'm going to show you how to create your first Python program here and run it from here. So this is the interface that you have with Python Anywhere. You're going to do everything from the browser. You're going to write Python programs and execute them from the browser. And I talked about the command line interface earlier. The command line interface can be accessed through the bash. So bash is another name for the command line, or sometimes you may call it terminal. So terminal, bash and command line, they mean the same thing. So click on bash. And this is the interface that you're going to use to interact with your Linux server computer. Now Python here is automatically installed, you don't have to install it, and it's the latest stable version is installed actually. And let's go and create your first Python program now. In order to write a Python program, you need an editor, a text editor, to actually write the code, because Python is the programming language that will execute that code, but you need an editor. On Python Anywhere you can use Nano. This is what I'm going to use. And basically what you do is you write the name of the editor program, which is Nano, and the name of your program. You can choose any name that you want, but it has to have the .py extension. So my program.py, click enter. Here you can start writing Python code. I'm going to write a program that prints out hello. Okay, this is very simple. You use the Python print function, so that's a keyword of Python, and then you print any text that you want, like that. But it has to be in quotes, just like I did it. Print hello. Then once you're done writing your program, you can exit your text editor. You can see these commands here. So Ctrl X will exit the program. So Ctrl X. So this asks you if you want to save the modified buffer, which is basically the text. So do you want to press Y or no? I'm going to press Y for yes. It doesn't matter whether it's capital Y or lowercase y. Like that. And finally,
Do you want to keep that name? So my program.py. If you want, you can press enter. Like that. Okay. Now, if you execute the command ls and press enter, you'll see that in your current directory, you have two files. There's a default readme.txt file contained in your Linux directory, and your new file that you have just created. So it's myprogram.py. Now you want to execute this myprogram.py with the Python. The commands to execute Python is Python 3. So that will execute Python version 3. If you want to execute Python 2, you just need to write Python like that. But we're going to use the latest version, so which is Python 3. And then after Python 3, you write myprogram.py. Execute. And this is your program output. So as easy as that, your program has a command, which was a print function in this case, and that print function gets some input. So in this case was a text hello, and so the duty of the print function is to print out text, and that's what the program does. And yeah, that's about this lecture. I'll talk to you in the next lecture. Hey, hi again. If you have chosen to use Python anywhere for this course, please watch this video. If you have chosen to work on your own computer like Windows and Mac or your own Linux computer, you can choose to skip this lecture. Python is a cross-platform language, so it doesn't matter whether you're using it on Windows or Mac or Linux, because the code, the Python code, is the same. So feel free to use any of the platforms. If you choose to use Python anywhere, in this lecture I'm going to show you the most useful commands that you can use to navigate your Bash console. So basically to navigate your computer, your virtual computer. So in this lecture, I'm going to show you how to list directory content, which we already did, by the way, with ls. And else, I'm going to show you how to get to print out the current directory path, how to create a new directory, how to create a new file, how to remove a file, how to go back one directory level, how to remove an entire directory, and how to copy a file, move a file, rename a file. And that's it. Those are the most useful commands that I'm going to show you right away now. So ls again lists the current files of the current directory. But what is the current directory? You should know that. You have the right to know. With pwd, you get the path of your current directory. So pm1 is the name of the folder. My username was pm1, so Python Anywhere creates your folder with that name. Now it'd be a good idea to actually create a directory where you put all your Python files, or let's say a directory where you put your files for the basics of Python, and then you create another directory for app1 and so on. To create a directory, you can use the mkdir command, and then you pass the name of the directory that you want to create. Let's say basics, like that. If you don't get any output, that means the command was successfully executed. You can do ls, and you'll see that basics now is here. So it's a directory. Now, if you want to go inside that directory, because currently you are in pm1, if you want to go inside basics, you do cd, which stands for change directory, basics. By the way, there is a good feature to use here. Once you start typing a name of a file or a folder, like BAC, then you can press tab for auto-completion, so that will complete the name for basics. So it will look for the current names, and it will just complete the name, so it's easier for you, it's faster. Then press enter, and now you're inside basics, as you can see in here. But if you don't trust me, you can do pwd, and you see that you are here. ls, it's an empty folder, so you don't get anything here. If you want to go back again, you can you can do cd and 2 dots, which stands for one directory level back. You see that now you're again in pm1. Let's go again to basics, and I'll show you how to create a file. Let's say you want to create a text file. You'd use the touch command, myfile.txt. You give the name of the file that you want to create and press enter, do ls, and you see that myfile.txt is there. You could also use the nano editor actually to create a new file or to open an existing file like nano myfile, press tab, .txt. So it's an empty file. You can start creating writing text there. I showed you already how to use nano in the previous lecture. Ctrl X to exit. If you want to remove the file, you can do rm myfile.txt, and the file will be removed. So you see ls returns an empty list now. If you want to copy a file from another directory, you can use cp, which stands for copy. Let me copy the myprogram.py file into the basics folder. But it's important to know where you are currently. Currently we are in the basics folder, so in that case you want to refer to one directory back, and then the slash, and then the name of the file you want to copy, like that. So that's the path of the file that you want to copy, and then you have to write the name of the file that you want it to have. So maybe you want to have the same name, like that. Press enter, ls, and you see that myprogram.py is here. If you wanted to do it the other way around, let me remove my program. You could also have done like a cd, go back to the pm1 directory, and then copy my program, and then you do basics, like that, slash, and give the name of the file where you want to copy it. So basically the content of this file will be pasted in the content of this new file that you're creating in the basics directory. And that should do it. Let me clear the bash console, like that. So currently we are in pm1. If you want to list the content of the basics directory, you can do ls basics. So you see that you have myprogram.py. If you want to move a file, you use v. So myprogram.py of the pm folder. So note that when I'm inside the pm1 folder, you don't use the pm1 like my program. This would be wrong, because in that case, Linux, the bash, would search for a folder named pm1 inside the pm1 folder, which doesn't exist. So you just use my program, and where you want to move it, you want to move it to the basics folder. My program, let's say 1.py. Again, if you do ls basics, you'll see that now you have two files there, while in the pm directory you don't have my program.py anymore. So to remove a file, you could use basic my program. Let's remove that file. Again, if you don't get any output, that means the removal, the delete of the file was successful. If you want to remove an entire directory, like let's remove the basics directory entirely, you want to use the R flag, which means for recursive. That means it will delete all the files of the directory you're referring to, like that. So for directories, use the R flag with this dash. Missing operand, this is the error you'll get when you don't use a command as it should be. So in this case I use rm without specifying the file I want to remove. ls doesn't need a parameter, so you see you only have readme now. You deleted everything else, so you deleted the folder. To rename a file, you can use mv. Let me remove this file to readme.txt. ls, you see that the name has changed. And yeah, that's pretty much what you need to know about how to use a bash console on Linux. And attached in this lecture you have a text file with a complete list of commands that you can run on on the bash, but these ones are the most important ones. If you can use these ones, you'll be good to go. You can call yourself that you can use a Linux computer. So I'll talk to you in the next lecture. Great, I already showed you how to create a Python program, which was very easy to do. I could create a folder, go inside that folder, like that. Use the nano editor to create a file. And start coding right away there. And press Ctrl X, Y, and enter. And then you could execute that program like that, and you get the output. So that's a standard way to create and execute a Python program. However, there is also another way, which is to write code interactively, to actually write and execute code interactively. What I mean by that is, besides using Python to execute a program, a Python file, which is basically a program, you can also use Python without any argument, without any parameter. So just Python, press enter, and that will actually start the Python interactive shell. So this here is called the Python interactive shell. And again, here you can use Python code like that. Just type it and then press enter, and that will execute the code like that. So the interactive shell is good for testing things out. If you're writing a program, of course you're going to write it in a file, like a .py file. But while you write it, you may want to test things out because you're not sure how some parts of the code work. Here you get the output right away. So it's a quick way to test the code. You can also use this as a calculator, like that. I'm going to cover these things later, by the way, but just to show you that this is also possible. Something important to know is that you can exit the shell with exit and round brackets like that. And once you exit the shell, basically you have lost this code. So it isn't saved anywhere like it was saved with the file that we created earlier. So the file my program.py has the code for you, but the Python shell doesn't save the code in any file, so it's basically lost. That's about this lecture. I'll talk to you later. Hey, hi, and welcome to this new section. In the previous lectures I mentioned that we'll be working on this program. So I'm going to break down this program line by line, so by the end of the lectures of this section you're going to understand what each of these lines does, and you're going to understand each of the keywords of this program. And so this piece of code basically includes all the Python fundamentals. That means if you understand this program, you will be able to make similar programs later on. So in this particular lecture, I'm going to run this program and explain the output of the program so that you have an idea of what this program does. I'm going to use Python Anywhere, so which gives you access to the Linux server. You can use your local Python if you like. That's perfectly fine. But if you want to have the files in the cloud and be able to run Python even from a mobile phone or even a tablet, so this gives you the possibility to do just that. So please download the basics.py file from the lecture resources in this video. I have attached it, also together with sample.txt file. The sample.txt file is a text file that is used as a data source by the program. So basically this has a dataset that our Python program uses to query some data. And you'll also find attached a diagram.png file. This is a diagram I made. This is the code actually that I just showed you, our program. Here I have highlighted all the components of this program. Basically they are all the components of a Python program, all the fundamentals of the Python program, such as, for example, if you want to know what is something that has a dot in front, so for example .read with brackets, and this has this rectangle that I drew here, orange. So you see, orange is a method, and you also have some examples here of a method, of a Python method, and so on. You have also other components of a program. So keep this somewhere safe, and I'm sure you'll use it. Now, the next step is to upload the basics.py file and the sample.txt file into Python Anywhere. One way to do that is to go to the Files menu, and then make sure you are in the directory where you want to upload the file to. Currently I am in home pm1. I want to go to home pm1 basics. That's the folder I want to upload basics.py. In just a few seconds you'll have the file there. Also sample.txt. Like that. Then go again to consoles. And you'll see that the console that I had opened in the browser is still here. So if I open this, you'll see that I'm still in the basics folder, so the processes will not get lost when you close your browser. The console is not closed, your browser tab is closed, but not the console. So you can find the consoles in the consoles menu. Okay, now if you do ls here, you'll see that basics.py and sample.txt are here in your basics folder. I can just go ahead and run this now with Python 3. So, what the program is doing is it's printing out this text flat floor street 18, which is the address of a certain grocery store. So this program is made for store employees, and it prints out the address of the store. So these are fictional data, by the way, that I created. Then the program asks the user to enter a PIN. So the PIN code of the employee. Let's say there are a number of employees, and the program wants to authenticate if this is an employee or not. I know that one correct PIN code that is inside the .py script is 1234. Once you execute that, the program goes to the next step. It asks you, the employee, to enter the fruit name that you want to know whether it's in the database or not. So the database in this case is a sample.txt file, which basically contains 3 lines. It contains the line apple, orange, and banana. So let's say someone from the departments of the store puts this sample.txt file in a certain folder, and the program.py accesses this file, and the employee then checks through the program if a certain fruit is in the sample.txt file. In this case, we want to check for orange, which is actually in the sample.txt file, and so the program tells us that the fruit is in the list. And the program ends, as you see here, you see this line, the current directory. So the program has ended successfully. You didn't get any error. So through this program, the employee knows if a fruit is available in the store or not. Now if we run this again, enter a wrong PIN code, in this case an incorrect one that doesn't exist in the file. So the program says incorrect PIN. This info can be accessed only by Mike, Joe, and Jack. So as you see, the program is intelligent. It reads your input and it produces some output depending on your input. Don't worry if you don't understand any, some certain aspects of the program, how it does that, because we're going to explain that. So let me run this for another last time. I'm going to input the correct PIN again, but this time I'm going to input a fruit which is not in the list of sample.txt, like melon, and the program says no such fruit found. That's it. Here is the sample.txt file, by the way. So apple, orange, banana. Ctrl X to exit. And yeah, that's about what the program does. In the next lecture, I'm going to open the code and explain you the code line by line. See you there. Hey, hi again. In this lecture, you're going to learn about variables. And in our program, basics.py, we have lots of variables. Now, something important that you should know is that a Python program is made of data objects, functions, and variables. So basically, these are the three components you need to know for now. So again, data objects, functions that do things on these data objects, they manipulate them, they get them and print them out, these data objects, etc. And you also have variables, and variables are used to store these data objects and also to store these functions in variables. So the interaction of these three components make up a Python program. Now let's look at some variables. All the names that you see in this format, so address equal to, this is a variable. So basically here we are assigning a data object, which is this thing here. We'll cover that later. We're assigning that to a variable. So in other words, the variable is like a container where you can put this object. This is also a variable. This one as well. So everything that is preceded by an assignment operator is a variable. Now I'm going to open another browser page. You can right click here and go to open link in new window, and then just put this window in here, and also this one in here, and I'm going to open another bash console. So now I have two consoles in two separate windows. And here I'm going to start an interactive Python session so that I explain new things interactively. I'm going to create another variable here, greeting for example, equals to hello. So once you do that, basically you are storing this text in this variable, so which is a name. And now what you can do is print greeting, and what you get is the value that the container, the variable, is holding, which is hello. If you want, you can update that to hi. Press the upper arrow key to call print again. So print greeting, you'll see that this time you get hi. So basically variables are used to organize your code so that you can define something here, but then you have lines of other lines of code here, and then you refer to that name again. You can update it and so on. You're going to understand variables later as we look at this program and other programs. So you'll see that the role that the variables play in real examples. So you can choose any name for variables, but there are some rules. For example, you cannot start the variable with a number like that, because you'll get a syntax error. So you're not following the rules of Python. You cannot start variables with a number. You can have a number somewhere in the middle or in the end of the variable name like that. That would be fine, but not in the beginning. You can also start variables with an underscore like that, and you can also use capital letters like that. However, this is not recommended. Technically it's not a problem, but it doesn't follow the standard conventions of Python. So just use lowercase letters for variables. Now, in a variable you can store different kinds of objects. Actually, you can store everything in a variable. So in this case, we're storing a string. So this is called a string or a text, but technically in Python it's called a string. So here in our program, this is not a string, it's not a number. This is called a list. We're going to cover that later. So for now, I'm not going through this program. We still have a few basic things to learn before we go and explain the first line here. So in the next lecture, I explain you strings. And then in the lecture after that, we're going to cover numbers. And so I'll talk to you in the next lecture. Hey, hi again. In this lecture, you're going to learn how to check for multiple conditions. And so let me create a check numbers.py script. Let's ask the user for some input using the input function. Enter number, like that. Since we're working with numbers, it's good to use float, so to convert the input to a float. And then let's say this is a program to check if the number submitted by the user is less or greater than 100. So we will do if user input is greater than 100, print out greater, else print out smaller. Ctrl X, Y, and enter. Python 3 check numbers, enter number 99, you get smaller. Enter 101, you get greater. Okay, so far so good. How about 100? You get smaller. So why did we got that? Well, we got that because the program checks if the user input is greater than 100. Well, 100 is not greater than 100. Therefore, the actions under else will be executed, which is smaller. That's why we got that. So if you want to print out a message that says, oh, that number is equal to 100, in that case you need another line here, which will start with elif. And after that goes the condition you want to check. User input is equal to 100. Print out equal. And that's it. Ctrl X, Y, enter. And the command line is not working well. Let me do a clear. Python 3, check numbers. So if you enter 100 this time, you will get equal. If you enter 101, greater and smaller. So that's how you make this work with multiple conditions, and you can add as many elif blocks as you like in here. So you could check for other conditionals and you just add elif and the condition and the action under that, and then elif and the condition under that, and so on. And also the else block is not mandatory in this case if you have elif, so this will still work. A 100, you get equal. 99, 101, you get greater. Now if you submit 99, you don't get anything because you're not counting for that case. So the code will not return any error, but you should know that if you're not checking for the last condition that is not included in this, then you'll not get any output from the program. And that's it. I'll talk to you later. Hi, and welcome to this new lecture. In this lecture, you're going to learn about a very important concept in Python, and that is custom functions. We already looked at built-in functions in Python. And for example, the len function was a built-in function, so it's already built in Python. Python developers have built this function to get a sequence as an input, like a string or a list or a dictionary, and return the length of that sequence. Or in other words, the items, the number of the items or the characters of a string. So built-in functions have been created to do popular operations. However, you'll see that as you program with Python or with any other language, you'll see that you may need functions that do custom things, such as, for example, in our case, in this program, this function, what this does is it reads a file, so it opens a text file in Python, and then it reads the content inside that file, and then it checks if a given word is in the text file, in the content of the text file. So Python doesn't have a function to do this thing, therefore you want to create such a function. Well, it's not mandatory to actually have a function here, because you could have these lines outside of this function block. So these lines don't necessarily need to be inside a function. But having a function, so wrapping these lines, these actions inside the function, so reading the file and checking if a string is in the file, putting these inside the function, it's a good practice. It actually keeps your code more organized. So it's good to put certain actions of your program inside functions to organize it in one function. And maybe you have another thing, you could put it inside another function, and so on. So in our program, we're checking for user input in here. The user enters the pin code, and we check the pin code against the dictionary values. And so if the pin code is found in the dictionary values, then we want to execute this function in here. So here is how we call the function. We define the function here, and we call it in here. So that's in general about custom functions. That's the idea. Now in the next lecture, I'll show you how to create a function, and I'll show you the syntax, the correct syntax, and the components of a custom function. So see you in the next lecture. Hi. Before I go ahead and explain this function line by line, first I'm going to write a more simple function than this here, so a more basic function. And what this function will do is it will get as input a value, which let's say is the birth year, and it will calculate the age of the person for that particular year of birth. So as simple as that. And the syntax for creating a function is always with the def keyword. So it starts with def, which means define. And then you want to define the name of the function. Calculate age. And then you have round brackets like that and a colon. Now, inside the round brackets goes the argument of the function. So in this case, let's say year. Now you can write anything in here. So this is basically a variable that will be used inside the function definition. And press enter. And then you want to indent 4 white spaces. 1, 2, 3, 4. So that's the syntax, everything that is part of the function. So the processes that this function will do, the procedures that this function will do, has to be indented. Let's say age equals 2. So how do we calculate the age? Well, that would be the current year, 2018, minus the year of birth, which is represented by variable year here. So here, and then enter. You want to indent again 4 white spaces so that the next line is at the same indentation level with the previous line. And then you use the return keyword. Return like that. That's a keyword of functions, of function definitions. And you want to return age. Now you press enter once. And if you want to add more lines, you do 4 white spaces and type again here. If you don't want to add more lines, you want to press enter one more time, like that. And as you see, we got these 3 arrows here, and nothing happened. Nothing happened because all we did is we defined a blueprint for doing something. We are not doing any calculations with real values. We just have some names, some variables, like this and this and that. This is a number actually, and I know that this is a very stupid function. Basically, if it's not 2018 now, this function will fail to calculate the real age of a person. But there is a way to do that. We're not going to do it right now. So there is a way to actually generate the current year dynamically in Python. I'm going to cover that later in later sections. So for now, let's keep it as a constant. So 2018. Once you have created your function in your script, so this is a Python session, an interactive session, but you could have this in a Python editor, like here, like we have it here, the function here. And so once you create your function, you can call it calculate age. Let's say birth year is 2000. That's not my year of birth, by the way, but... And yeah, this is the age, 18, which I think is what you were expecting. And now let me explain a few things in here. This is the keyword def. This is the name of the function. You can pick any name that you want, but it's advised to actually use lowercase letters for the function and use underscores if your function has more than 2 words. Like in this case, calculate underscore age. Don't use spaces. So the same rules apply as with variables. And then you have these round brackets. Inside the round brackets, you enter the argument. The argument also follows the naming rules of variables. Now, you can also have functions without arguments, like printing, for example. No arguments there. So this is simply printing hello. And the way that you call this is like that, without arguments. Hello. Now, when you define the function, this is actually referred to as parameter. So when you write it in here, in the function definition, this is referred to as a parameter. When you pass the value of the parameter, this is called the argument in the function call in here. Now you see that here I used return and here I used print. Now I'm going to explain the difference between using return and using print, but I'm going to explain that in the next lecture. So I'll talk to you there. Hello, here we are with yet another lecture about custom functions. And in this specific lecture, I'm going to explain you the difference between return and print. Specifically, you will understand when to use one or the other. And so, I've created a file, a Python file with a nano text editor. I called it returnprint.py. That's the name of the file. And I have 2 functions in here that I have created. So the first, I called it returning. It has no parameters. And all this function is doing is it's executing this return 10 statement. So it's returning number 10. In reality, you'd never need a function that returns number 10, but this works to explain my idea. And then we have another function. I called it printing. It has no parameters, and all it does is it executes this function, so the print function. The print function will print out number 100. And here I'm calling the returning function, and here I'm calling the printing function. So let me go ahead and Ctrl X and Y, enter, to save the script, and use Python 3 to execute the script. You see that we got 100 executed. So keep that in mind, 100. Why did we get 100 executed? And why didn't we get 10? Well, that's because the returning function is not printing out, so it doesn't have any print function. It's true that when we use the interactive shell and we had a function that had a return statement inside, and then we just called the function and we got the output printed out. Well, that's because that's how the interactive shell works, actually. So basically, when you call a function or when you just call a variable without a print function, it will just print out the output because it thinks that your your purpose was actually to see the output of that function. So basically the interactive shell will implicitly add like a print function in your function call or in your variable, and it will print out the output of that function. But this is not how it works on a Python file, on a Python program. So in a Python file you want to be explicit, which is in this case, if you want to print out the output of this function, you want to use a print statement, the print function, sorry. So Control X, Y, enter, execute, and you'll see that in this case now we got 10 printed out correctly. Now the question remains, should we use return or should we use print? Both them seem to be doing the same thing. Well, the short answer is you should use a return, the return statement, almost always. I'll tell you the reason why. In this case, our interest was to actually just print out the value, but what if you want to reuse the output of your function? So let's say we want to add 20 to the output of the function, because in reality that's what you're going to do with your function outputs. You're not going to simply print out the function outputs all the time. Most of the time you're going to reuse the output, like to add other numbers to that or manipulate it or any other things. So if we do this now, and if we do the same for this plus 20 and execute, see what you get. So you get 30, which is the output of 10 plus 20. So 10 was the output of the function, and 20 was what we added to the output. Then we get 100, and then we get this error. It says non-type and int cannot be added to each other. So non-type is actually the output of this function. It's a non-type because this function is not returning anything. Actually, when there is no return statement in a function, the function will return none, which is a specific type in Python. You can actually check that. Let me cut these lines with Control K. So print type returning with those brackets there, another bracket for the print function, and print type print. And so we also need a third closing bracket. So 1, 2, 3 opening brackets, 1, 2, 3 closing brackets, and the same goes for this one in here. Execute again, and this is what you get. So you get class int. So the output of the function which has a return keyword is actually an integer. So number 10 is actually an integer, or in other words, the output of the function is an integer in this case. So the type, but the type of the function that doesn't have a return keyword is non-type. So when Python, when the function doesn't have a return statement, then Python implicitly applies return none, so the none object. Therefore, you should use return whenever you can to return your values, and then use a print function in here to print out the value of the function if you like, to print it out. Otherwise, you'd get this specific Python type. So that's the non-type that we got there, class non-type. This is what Python will return when there is no return keyword. Yeah, that's about return and print, and I'll talk to you later. Okay, now that you got an idea on how to define functions, we can safely go back to our program where we left it, and I'll explain you these lines now. So, to give you a summary, the The program asks the user to enter the pin code. The user entered pin code. Let's say they entered the correct pin code that is located, that is found in the dictionary. And then the program asks the user to enter a fruit. And then the fruit name is passed as an input to the function. So as you see here, we are using the print built-in function to print out the output of the find in file function, which is defined up here. So basically, if the user enters orange in here, let me execute this to explain it better. Python 3 basics. Enter your pin 1, 2, 3, 4. That's a correct pin code. Enter fruit. So if I enter orange here, this orange string, so here we are, this orange string will be stored in this fruit variable. Okay, so the fruit variable will be equal to orange at this point. Therefore, the function will be executed using the orange string as input, as argument, as the value of the argument fruit. And so orange then will be assigned to this parameter here. So basically this f will be equal to the string orange. And what will happen is, now with these lines I'll explain them briefly because I'll go through these processes later on in more depth. But basically what these are doing is we're opening the sample.txt file as a file in Python, as a file object, and then we read the content of the sample.txt file, which by the way contains three lines. It contains orange, apple, and banana. And then here we create a list with this method. So the Python list will have 3 items. It will have the item orange, so the string orange, the string apple, and the string banana. So a list with just like this, but with those strings, fruits. And so then we check if f, so f is orange, because that's what the user entered. If orange in fruits, which is the list with items orange, apple, and banana, if orange is in that list, we will return this string. That fruit is in the list. Else, which means if orange is not in the list, we will return no such fruit found. As simple as that. So orange, enter, that fruit is in the list. Now you see that this function is not as simple as the one we created earlier, like not as simple as this. It has more lines, and you'll see, if you look closely, you'll see that we have a conditional here. So you can have conditional blocks inside a Python function definition. You'll see that the conditional starts indented just like the other lines in here. And then the action that is dependent, that is part of the conditional block, is also indented under the condition in here, which means we have 4 white spaces in here, and then we have another set of 4 white spaces in here, which means 8 white spaces in total. Then else is in the same level, indentation level with if. And then we have another indentation here for the next return statement. And yeah, that's the idea. And yeah, that's how this function works. A couple of lectures later, I'm going to explain how to handle files in Python, so don't worry about these lines, these 3 lines for now. I still have to tell you a few more things about functions, and then we move on to this file handling. So I'll talk to you later. Hey, in this lecture, I'm going to talk about functions, custom functions with more than one parameter. So you saw functions with no parameters at all, like these 2 functions in here, and you saw a function with 1 parameter, like this one in here. But you can also have functions with more than 1 parameter, so multiple parameters. So let's say I want a function that converts one unit to another unit. Let's call this converter. For example, we would want to maybe convert feet to meters. Let's say a parameter called original unit and the coefficient. And then you go here and you say to return original unit times the coefficient. Let me delete this. Control K. And I'll call the function in here converter. So original unit, let's say I want to convert the feet to meters. Well, let's say I have 10 feet and I know that 1 feet is 0.3048 meters. So that's it. Exit that. Python, and the name of the function was, by the way, I pressed tab to help me with the available files that I can execute, because I didn't remember the name of that script. So it's return print.py. And yeah, this is what you get. You get the output of the function. So this should be meters. But let's suppose that you're going to use this function mostly for converting feet to meters. In that case, you don't want to pass all the time this 0.3048 in the function call. So it's better to actually put that as a default value for the coefficient parameter here, so that you can only pass the original unit. And then rarely, if you want to convert another unit, so let's say you want to convert kilometers to miles, then you pass kilometers here, and then you'd need to use a specific coefficient for kilometers, but you still want the function to work. And I'll explain how to do that in the next lecture. So talk to you there. Hey, hi again. As I told you, I'll show you how to have a default parameter. So functions can have default parameters, and the way to do that is by specifying the value in here. If you do that, then you don't have to pass the value for the coefficient if you're accepting that the value of the coefficient you want to use is 0.3048 in this case. So I'll exit this and execute and see what happens. You see that you still get the same output. So that's good, because it's very efficient to not having to use that value in your function call. But if you want, you can change that by just passing another value. Let's say you want to convert miles to kilometers. That's around, I think, 0.62. So you want to explicitly pass that parameter there and try out the code. And you get 6.2. So 10 kilometers is equal to 6.2, if I'm not wrong, with the coefficient. And yeah, that's how you can have default parameters in your functions. This is about it. I'll talk to you in the next lectures. Hello! In this lecture, you're going to learn how to open an external text file in Python and how to extract the content of that text file and display it with Python. So here we are with our program. The way to open a file and read or extract the content of that file is by using these two lines, basically. So I told you earlier that a Python program, the structure of a Python program is made of data objects such as lists and dictionaries and strings. And so it also is made of functions which do things on these data objects, such as a print function is printing out these strings in here. You also have methods which are like functions, but for the sake of simplicity, let's say you have functions and data objects, since methods do the same thing as functions, but in a slightly different syntax. And so now I'm going to close this script and demonstrate you how to open and read text from text files from scratch. So this is the basics folder. It's in this directory, home pm1 basics, and here we have this sample.txt file in this directory, which looks like this. So what I'm going to do now is I'm going to create a program that opens that text file in Python and reads its content and displays, it prints out the content of the text file on the terminal. The way to do that is you want to create a variable where you want to store the file object, like you have list objects, you have dictionaries, and you also have file objects. So that will be equal to open. Open is one of the built-in Python functions, just like print. And so the open method is what creates a file object, just like the input function would create a string given some user input. So it gets user input and it converts it to a string. The file object will convert this file into a Python file object, because Python here behaves just like a text editor, let's say Microsoft Word, which is used to open a text file. For example, you can open this sample.txt file in Microsoft Word and display it in Microsoft Word. In this case, we're not using Microsoft Word, we're using Python. And so then we want to create another variable where you want to store the text of that text file. So those three lines, apple, orange, and banana, will be stored in this file as a string. Once you have done that, I want to print out the string. However, there is one more process here that you want to add, which is myFile.close. What this will do is it will close the file object, and this helps to release resources from your computer, so to release memory resources. You can also remove this, that won't be a problem because this is just a small file, a few kilobytes, so it won't do any harm, but it's a good practice to basically close the file object once you are not using it anymore, because after this line we're not referring to the myFile object anymore. We created a variable, stored a string in that variable, and we're printing out that variable, but we don't need myFile. So close this, save it, clear the terminal if you like, and run the script. And this is what we get. So the content of the text file was printed out successfully. Let me demonstrate one more thing through the Python interactive session. So we were able to open sample.txt, and if you do a type myFile, you'll see that this is a special object. It is called text.io wrapper. You can call it a file object. That's how everyone calls it, and that's how it was used to, and that's how it was called in Python too. So that's the reason why everyone still calls it a Python object, a Python file object, not a text.io wrapper. Anyway, this myFile object has these methods now. So we use the read methods. There are other methods as well that we'll cover later. No, myFile.read will give you this. As you see, we have this \n characters here, which seem to be not in our text file, but these are actually break lines. And when you use the print function, here we didn't use the print function, but if you use the print function, these will be displayed as break lines. So the print function basically knows how to display these. But anyway, now you know how what these are. I'm going to talk about them later. For now, if I again execute the myFile.read method for a second time, we will get an empty string. So why is that? Well, in Python file handling, there is the concept of the cursor. When you're just opening a file with the open function, the cursor is at the very first position of the text file, so just before the first character. And then when you apply the read method, the read method will read the text and it will move the cursor down to the last position, so just after the last character. So now, after you apply the read method for the first time, the position goes at this point here. Therefore, if you apply the read method for the second time, the read method will read under the cursor. That's what the read method does. And so under the cursor there is nothing after the last character. That's why we get this empty string here. If you want, you can move the cursor up to the very first position, to position 0, using myfile.seek. And then if I apply myfile read again, you'll see that the text is there. That's the idea. You can also use print if you want to see it in a well-formatted style, like this. And yeah, that's what I wanted to teach you in this lecture. I'll cover some more about handling files in the next lecture. See you there. Hello again. In the previous lecture I showed you how to read this text file with Python. And so we created this Python file and we wrote the code in that file and we ran that file from this directory. So that was our working directory, home pm1 basics. The fact that we ran the Python program from this directory and the file that we processed was in this directory, that allowed us to simply pass the name of the file in the program. But what if that text file was in another directory? Let's create a directory. Let's call it files. And I'll move sample.txt to files sample.txt. So you see that now sample.txt is not here anymore. It's not in the basics folder. Now, if you run the program again, open file.py, you'll get an error. It says file not found error, no such file or directory, sample.txt. And that's correct, because we don't have that file in this folder. The way to correct that is to go here and supply the correct directory here, which should be files/sample.txt. That now should work fine, as you see. Let me clear this. How about another scenario, like if the sample.txt file, we move it from here and we place it one directory up, sample.txt, like that. So you'll see that sample.txt is not in the basics folder, and it's also not in the files folder, but it's one directory up, so it's in the pm1 folder. It's here. So with this I was able to move the file one level up. In this case, the best thing to do is to actually provide the absolute path of the file. So in this case, this is just a relative path to the working directory, so to the directory where you are executing Python from, which is the basics directory. And the best thing to do in this case is to provide the absolute directory path, like that. That's the directory of that file now. If you execute, you get the correct results. So as you see, this is the absolute path of this directory. So the absolute path starts from the beginning. Anyway, if your project has a root directory and you know that all your files will be not outside this root directory, but it will be in subfolders of this root directory, then you don't want to use absolute paths you can just use relative paths where you specify the name of the folder the file is and the name of the file, like we did earlier with basics/sample.txt. I hope this is clear, and I'll talk to you later. Hello, and let's go back to our program now, which is this one in here. And specifically, we're going to look at these 3 lines now that you know how to open a file and how to extract the content of that file with Python. It's easy for you to understand these lines. However, maybe you're not very clear about this 3rd line, so I'm going to explain that. First, let me make a summary of what the program does. The program starts executing these lines, it prints out something here, and then it asks the user to enter a pin code. The user enters the pin code, then the program goes to the next line. It reads the function definition. It doesn't do anything because Python doesn't return any output when you define a new function. It's just a blueprint. So then it goes to the conditional here. It checks the pin that the user submitted in here. It checks if that pin is in the values of this dictionary. If it is, then the program will ask the user to enter some more input. So to enter a fruit name. The user enters a fruit, let's say apple, and then that apple string is passed to this function. So to the function that you define in here. So now we're executing the function. And so apple will be stored in this variable f here, in here, and then we open a file object, which is the file object for the file path sample.txt, and then we read the content of that file. So what are we doing here? Well, I can demonstrate you that by adding here a print function where I want to print out the fruits variable. So print functions are good to use to show intermediate results, to know how your code is going on. And that's what I'm doing in here. I'd also like to add a string like that, so that I know in the terminal what output is what. You'll see that. Okay. Python 3 basics.py 1, 2, 3, 4. And so this is what we get out of our print function. So the print function printed out the string fruits that I entered, and then the apple, orange, banana. So the content is being read successfully. However, I told you about these break lines, and in Python internally they are like \n characters. So basically, if you do print hello \n and then world, you'll see that the \n is treated as a break line. That's what we have here as well. If you want to see that this is actually a \n, you can use R, which stands for row. So you want to see the row string, the row version of the string using R. So therefore, what I'm trying to get is that this split lines method here, what it does to this list, to this string, is it removes this \n characters. And it actually creates a list object where each of the strings divided by these characters is placed as an item. So if you had more, like that, you'd get a list with 3 items, and so on. And that's the idea. Let me cut this with Ctrl-K. And you can print out the fruits in here after you have split them with split lines. Execute again. 1, 2, 3, 4. So you see that the fruits after split lines becomes, from a string, it becomes a list. Therefore, now you have a list with clean items without any extra characters. And therefore, what we can do now, as you see, we check if f So f is holding the string that the user input, that the user submitted in here. So if banana is in the list, which is like this, banana in so you get true. If banana is there, you get true, so this is evaluated to true, therefore this will be executed. So that fruit is in the list. Otherwise, if banana is not in the list, or if the fruit that the user submitted is not in the list, like melon is not in the list, you get false, therefore this is not executed, and the statement, the expression under else, is executed. So that's what the function will return in this case. Yeah, that's the idea. I hope this is clear, and if you have questions, ask them in the Q&A area section, and I'll talk to you later. Hey, hi again. In this lecture, I'm going to cover strings in Python. As you are realizing, Python is made of different data objects, so which can be strings, number, and lists, such as this one here. So in this lecture, we're going to cover strings, and here I have an interactive Python shell here on the right. So you saw that print hello is actually a string. Another way to write strings is to use single quotes. So this would be fine too, hello, like that. So how do I know that this is a string? Well, you can use a type function, and you'll see that this is str, so it's a string. You can store a string in a variable, like the variable myString, hello world, like that, and then just call it, and you'll get it printed out like this. And strings are made of characters. So for example, this string has 1, 2, 3, 4, 5, 6. The space is also considered a character. 7, 8, 9, 10, 11, and 12. You can check the length of a string using the len function. You'll see that you get 12. So the length of a string is 12 characters. Even numbers enclosed in quotes are actually strings. You can check the type of this, and you'll see that this is a string. So you'd probably ask, why is that? Well, Python has to divide things very strictly. So it has to know the type of value that you're using, that you're passing to the program, because in certain scenarios it might make a difference. For example, if you do 100 plus 100, with quotes like that, Python knows that these are strings, so it doesn't perform a mathematical operation, but it does perform a concatenation. So it basically concatenates these two strings, and it says 100 and 100. Now this is different if those were numbers, and so I'll explain numbers in the next lecture. See you there. Hey, welcome again. This is yet another lecture, and this is the last lecture that is about this program. And as you may guess it, we're talking about these last two lines. These are the very last lines that we haven't covered yet. So we covered everything from the first line to this line here. And what is this? Well, this is a for loop. What a for loop does is a for loop goes through a sequence object, which could be a list, a string, a dictionary, and it goes through all the items of that sequence, and it does something to each item. Let me go ahead and demonstrate that. Let's say A is a list 1, 2, 3, so it has 3 items. What if you want to print out each item in each line? Well, you could do print A0, print A1, print A2. So you'd have a script with these 3 lines of code, and you'd get 1 to 3. However, what if you have a list with 100 items? You don't want to execute the print function 100 times. You don't want to type down the print function 100 times. What you do instead is you do for and pick a variable, let's say I or item, whatever you want, in a print item. And this is what you get. 1, 2, 3. You could do that for lists, you could do that for strings. For item in a print item. As you see, you could also do that for dictionaries. Let's say pins is a dictionary. For item in pins, print item. And you get Mike, Joe, Jack. As you see, this is a bit different because this is printing out the keys of the dictionary. So when you just do pins, it prints out the keys of the dictionary. If you want to print out the values of the dictionary, you do pins dot values. Print item. And you get 1, 2, 3, 4, and so on and so forth. Also, I want to tell you that the equivalent of for item in pins is the same as doing for items for item in pins keys. Print item. And that will give you the keys one by one. And that's exactly what we're doing in here. So let me exit this and execute basics.py 1, 2, 3, 4 banana. As you see, in this case, this is not executed. So the expressions under else are not executed because this condition here was evaluated to true. But if you enter an incorrect pin, you see that you get Mike, Joe, Jack. So this is just to show the user that this info can be accessed only by, so which is here, print incorrect pin, print this info can be accessed only by, and then next the for loop will print out each of the keys of the pins dictionary. That's the idea. Of course, let me open a Python shell again. Of course, that to print function, the print function is not the only thing you can do under an for loop. You can also do other things like create another variable like c equals to I plus 10, and maybe then print c again. So as you see, you can do operations under the for loop. And the way this works is now the for loop, what it does is it works with iterations. So it starts with by assigning the first item of this sequence to the variable I. So this is a variable in this case. So in the first iteration, I will be equal to 1. And so what you do is you create a variable c equals to 1 plus 10, which means c will be equal at 11 for now, and then you print out c. That's why you get 11. And then the loop will go again to the list. It will check if there are more items. In this case, there is another item, which is item 2. So I will be assigned the value of 2. And then c, which currently has a value of 11, will be updated with 2 plus 10. So c will get the value of 12. And we print the value of c, so we get 12. The loop again checks if there is one more item in the list. Yes, there is. So again, e is equal to 3, c is updated with 13 and printed out in here. And then the for loop goes again to the list. Are there more items? Well, there are no more items, so the loop ends. It terminates, and then the program also terminates. That's the idea. You can also iterate through the file, like like that. C, which is the content. So C at this point is just a string. If we iterate through that for now, for I in C, print I, what we get is we get the string items one by one, because the string, the items of the strings are characters. But we don't want that in this case. We want to print out the words one by one, not the characters. And therefore we need to convert C into a list using split lines. As you see, C now is a list. So if you do for I in C, print I, you get apple, orange, banana. So that's about the for loop. For loops are very powerful, as you see, when you do batch operations. So when you apply a function or a method or some operations multiple times, using different items in some compound data types such as lists, dictionaries, and strings. And yeah, I hope this is clear, and I'll talk to you later. Hello, we have a few more lectures to go before we close this section of the Python basics, and before you consider yourself that you know the Python fundamentals and you can write basic scripts of Python. So a few lectures before this I explained you how to open and read data from a text file. In this lecture I'm going to show you how to create a new text file and how to write text in that text file. So let's go ahead and do that. I'm going to start an interactive Python session. You can use a python.py file if you like to write the code. Let me ask for help on the open function. You see that when we use the open function, we pass the file path, which is this argument here of the open function, and then we didn't pass any other arguments. You see this mode equals to R. This is actually the second argument that the open function gets. It's actually a default argument, so it has a default value, which means if you don't pass that argument, the open function by default will know that you're opening a file, an existing file in read mode. So your interest is that the file path that you're passing here, so for example sample.txt, your interest is that you want to read data from this text file. If you want to write data from a text file, then you want to specify the mode to another value, which I'll show you just here. Press Q to exit that. My file equals to open. Let's name this file employees.txt. And then you want to specify the mode, the file handling mode. So W. Now, what you just did is you created a text file in the current directory. So in my case, in the basics directory, you can check that in here, ls, in the sister bash terminal. So it should be somewhere here, yeah, employees.txt. Now, to write something in that file, you use the write method. Let's say Mike. Alright, you get 4, which means you just wrote 4 characters in that text file. So Mike has 4 characters. Now, if you open the employees.txt file, maybe you're expecting to see Mike there, but Mike is not there yet. The reason is that you haven't saved the changes in that file. To save the changes, you want to apply the close method. So this will save and close the file. If you exit that file and open it again, you'll see that Mike is there in the file. If you want to write multiple lines in that file, you could do something like this. You need to open the file object again to create it, and then let's say you want to add Joe \n Jack. So \n will behave like a break line. And actually you see that you got 13 there, which also includes the \n. So \n is considered one character. My file close this now and open it again to see the changes. So you get Mike, Joe and Jack. Note that anytime you execute these lines, what Python is doing is it is creating a new employees text file that overrides the existing text file. Therefore, what we have written there before, like we wrote Mike there, but Mike will be overwritten now by the new text file. So basically, every time you apply the right method to a file that has been opened with W mode, that right method will write from scratch, from the beginning. I hope that is clear, and you can also try this. Let me call this employees 2. You can write Mike. You can write Joe. Close the file and see what you got. So you get both Mike and Joe. As you see, you can apply multiple write methods to a file that has been written with, that has been opened with W, and those write methods will apply the string. So the first you wrote Mike was appended to the file, and then you wrote Joe, and Joe was appended just after the first string. That's what happens. So it's not the write method that actually overrides the existing text, because in this case the second write method didn't overwrite Mike, so Joe didn't overwrite Mike. It's actually this line here that overwrites a text, the entire file. It creates a new text file. Now if you want to show this one at each line, well, what you do in that case is, let me create overwrite the existing file. Let me close this first. So overwrite employees2.txt, and then what you want to do is write Mike. Mike will be written there, and then if you want to write another line, but you want the line to have a break line, you do \, first, and then Joe, like that. Close. You see that you have a break line there. So anytime you add a new string to the file, you need to use this \n if you want it to be added after a break line. Now, if you're interested to actually append some text after this existing text file, I'll show you how to do that in the next lecture. See you there. Hi, in this lecture I'm going to show you how to add another line into this existing text file. To do that, again, you need to use the open function to create a file object. Here, this time, you need to give the path of the existing file that you want to append text to. And then you want to pass the mode argument, which in this case has to be A if you want to append text to an existing text file. Like that. And then what you use? Well, you use the write method. So we want to add maybe Jack after Joe, and if we want it to have a break line, we need to use \n before Jack, like that. My file.close. Close this. No. Open again. You see that Jack is there. Now, you'll see that when you open a file in append mode, you cannot read from that file. Similarly, when you open in write mode, again, you cannot apply a read operation, a read method. So that kind of file open with that mode doesn't support read operations. But there is a solution, and I'll show you that in the next lecture. Hey there, let's now see how to read and append text to an existing text file. So we have this text file, we have Mike, Joe and Jack, 3 lines there, and we want to know what we have in the text file, and then we want to append some more data. Maybe you have a program that you first want to check if something is there, and then depending on that, so you have some conditionals there, and depending on that, you then want to apply a write operation, a write method, to append text to that text file. So how do we do that? Well, it's quite easy. Again, you use the open function to create a file object. employees2.txt, that's the path to the file. And then we don't use the a method, which stands for append, because that doesn't allow us to read, but instead we use the a plus mode. So that allows us to both read and write. Now, if you do my file.read, maybe you're expecting to read the 3 lines, but not. You don't read it. That's because the cursor with this mode is placed at the end of the text file. Normally with the R mode here, the cursor is placed on top of the file because Python expects you to read the text that starts from the first character and down there. But with an A+ mode, Python expects that you are appending text to your existing text file. Therefore, it places the cursor by default after the last character, so that when you append some text, the text is appended after this. Therefore, if you want to read, you first need to do myfile.seek and 0 if you want to place the cursor before the first character. Then you do myfile.read, and you get the text as a Python string. You see you have these break lines, and even after Jack I have one. Maybe you don't have it, I may have pressed enter by mistake here in the text file. It doesn't matter. And so once you read it, now the cursor is placed after the break line, so somewhere here, down here. If you write something now, like John, and then you want to close the file in order to see the changes in the editor. Let me exit this. No, for saving the changes. Open, and John is there. So that's how you read and write to a text file. I hope this makes sense, and I'll talk to you later. Great, in the previous lecture you saw how to create a string, and in this lecture we're going to cover numbers. I'm going to clear the Python console. You can do that using Ctrl-L, so that will work on Linux. If you are on Windows, it may not work, so it works on Python anywhere. Numbers are simply created like that. But there are 2 main types of numbers. For example, if you do type for A, you'll see that this is an integer. You can similarly do type 100. This is also an integer. So integers are whole numbers. Even minus 100 is an integer. So every number like minus 10, 0, 1, 2, 10, 100 and so on are integers in Python. You can try 0. And you also have floats, which basically are decimal point numbers, like that, and so on. Now, in the previous lecture, I showed you that 100 plus 100, each quoted as a string, it gives you this number. But if you use them without quotes, Python will treat them as numbers. So when to use a float and when to use an integer? Well, most of the time for mathematical operations, when you're interested in doing mathematical operations, you're going to use floats. But sometimes, for example, in this case, we have some pin codes. In this case, we're not interested about decimal points, so it's fine just to use integers. And by the way, it's also possible to convert between different data types. And we're going to cover that in the next lecture, which is about functions. So we use functions to convert different data types from one data type to another data type. See you in the next lecture. Hey, hello again. In this lecture, you're going to learn about built-in functions in Python. Actually, you already saw some built-in functions already, like type 10 will give you the type of value 10, which is an integer. Now, type is a Python function, so the syntax of a function is the name of the function, which has been created, has been defined by the authors of Python, those who have developed Python. And then you have brackets, and inside brackets you have the input of the function. So the function takes an input, which is 10 in this case, and it produces an output, which is class int. And you can get a list of all available built-in functions in Python using this expression. So you use the dir function, which is yet another function, and then you use a double underscore, built-ins, double underscore, and then close the brackets. Execute. You can ignore these for now. These are types of errors, so which you don't need to know for now. You can also ignore the things with underscores up here and start from here and down. So from apps and here. All these are built-in functions, and we already saw type, and we also saw print, which is somewhere here. The print function, the type function. There are other functions as well, which you can try, like length, len. We tried len for strings. It gives you the length of a string. In this lecture, I'll explain you the float function, the str function, and the int function. This may become very useful, and Ctrl L to clear the console. The int function, what it does is it converts a value, like let's say a float, from a float to an integer. So you see that from 8.5 you get 10. Even if it's 10.6, you get 10. So this is not a rounding operation. For round, you need to use round 10.6. And that will give you 11, which is the closest value, the closest integer value to 8.6. So see the difference between these two. And you can also use float to do the opposite. So if you have 10, it will give you 10.0, so the float version of number 10. And you can also use int for strings, like let's say 100. It will give you 100. So if you know why this is useful, well, if you have a string somewhere and you want to do a mathematical operation like that, so you see that this basically is equal to 100 plus 100, you get 200. Similarly, you can use float like that, and you get 100.1, which is basically the same as 100.10. And then you can use str to convert from integer to a string, or from a float to a string. Let me print out these built-in functions again and give you a task, an exercise that you can do. So you see all these functions here. You can try this out, and you can ask Python for help to show you what a function does. For example, you can do help len for the length function, and you see that this returns the number of items in a container. A container might be a string, as we did previously. Press Q to exit this. So Q. And yeah, try to use any of these functions to get familiar with the syntax of a function. That's about this lecture. I'll talk to you later. Hey there, until now this program has been sleeping here. I haven't still covered this because I've been explaining more basic things that you need to know before understanding this. In this lecture though, we're going to see the first line here and explain what this does. Because in this lecture I'm going to talk about Python lists, and this thing in here is actually a Python list. So lists are data types or data objects, if you like, just like strings and numbers. The difference is that strings and numbers are more simple data types than lists. Lists are more compound data types that may contain several strings or numbers inside them. So in other words, the definition of a list is a data type that contains multiple items. The syntax to create a list is to start with an opening square bracket, and then you start writing the items of the list. And each item, for example, the first item is a string, and then the first item is divided by the second item using a comma. And then you have a comma again, and then until the last item, and there is no comma after that. And then you have the closing bracket. Now let me exit this Python session. Make sure you are in the basics folder and execute the basics.py file. You see that we get flat floor street 18. So where is this coming from? Well, it's coming from this print function in here. The print function is basically printing out the first item of the list, which is flat floor street, this one here, and the second item of the list. So what are these zeros and ones? Well, let me Ctrl+C here to close this and start a Python session, interactive session again. Double click here, Ctrl+C, Ctrl+V here to paste that line. So address 0 will return the first item of the list. That's because list items have indexes. So each of the list items has an index, and it starts from 0. The very first item of the list has an index of 0. The second item has an index of 1, and the last item has an index of 2. If you pass 3 there, you'll get an error which says that index error, list index out of range. So basically the list doesn't have an item with index 3. You can check the length of a list using the len function, just as you did with strings. And now it's time to know that even strings have this indexing system. So 0 will get you age, 1 will get you E, etc. Even if you have spaces like that, so the space would be an item with index 0, 1, 2, 3, 4, 5. If you do 5 here, you'll see that you'll get a white space here. Ctrl+L to clear that, and let's stop at this line here. We covered the print function earlier, and you saw that the print function took one input, but it can also take more than 2 inputs, like hi, and you see that it prints out hello hi. And so these inputs, actually they are called arguments technically. These arguments have to be divided by comma, as you see there. So the same we have in here in this print function. So up to this point, what the program is doing is, because Python starts executing a script from top to bottom. So it starts with the first line. You are creating a variable. It stores a variable in the memory, and in that variable it stores this list. It doesn't output anything because you don't have any function that you're not saying print this out or do this or do that. You are just storing a variable in the memory. Then you store another variable, which we're going to cover later, And here is where you have a function that you tell Python to do something, to do an action with some data. So this is the function that is printing out flat floor street 18, the first two items of that list. So that's about lists. In the next lecture, I'm going to teach you some few more tricks about lists, and then we're going to cover this line in here, which is a dictionary. But first, let's go through the next lecture. See you there. Hey, hi, and in this lecture, I'm going to cover some more things about lists. You saw in the previous lecture that this was a list, and it had 3 strings. But you can also have a mix of strings and other data types, such as an integer in this case. So address with index of 1 is actually a number, and you can check that the type of that is an integer, which underlies that you can do mathematical operations with that. So 18 plus 20 is 38. In this case, maybe you're asking, why did we use a string here? Well, you could have also used an integer, but we're not interested about mathematical operations with these data types. So it's just fine to use text, so to use a string. This is just the street number, so it's fine to just keep it as string. Now, besides the normal index system that starts from 0 for the first item, 1 and 2, lists also have another indexing system that starts from -1 for the last item, then -2, -3, and so on. You can see that -1 gives you New York, -2 gives you 18, and so on. So this system is good when you have a long list, let's say a list with 20 items, and you want to access the last item, but you don't want to count from 0 to 1 to 2 to 3 to 4, so to count all the items, when all you want is to access an item that is closer to the right than to the left of the list. So this system is referred to as negative indexing. The other one is referred to as positive indexing. Now, besides accessing single items of a list, you can also access a slice of a list. For example, if you do address and you do 0 to 2 and close a square bracket, press enter, this will give you another list including only the first and the second item of the list. So this is a slicing syntax. You need to use this colon here. Basically what you're doing here is you're telling Python to give you items from 0 to 1. Actually this is 2, but Python ignores the last item. So in other words, it's upper bound exclusive. It excludes the upper bound, which is this one here, from the slice. So in simple words, if you want to access from index 0 to index 1, you'd have to put 2. If you wanted all the items of the list, you do 0 to nothing, so which means from 0 to the end. That would be similar to this. So this is saying get me everything from the start to the end, or get me everything from the start to number 2, index 2. So from the start, flat floor street, to item with index 1, since we have index 2, and so on. You can also do negative slicing, so from -1 to -2. That will actually give you an empty list, because Python cannot go from right to left. It goes from left to right when it does slicing. So if you wanted to get 18 and New York using negative slicing, you'd start from -2. So which means the first index is always included in the slice, just like it does with list, with positive indexing. So 0 is included in the slice, as you see, flat floor street. Also -2, which is 18, is included in the list. And since you have an open upper bound, this will include everything on the right of -2, which is New York. If you add -2 and -1, you only get 18 because the last item is not included in the list. As I mentioned, list slicing is upper bound exclusive. And this is about this lecture, and I'll talk to you later. Great, finally we're going to look at the second line of the script, of the program. So the first line was a list, and this object is a Python dictionary. Like lists, Python dictionaries are also compound data types that may contain multiple values, as you see. But in contrast to lists, Python dictionaries contain pairs of keys and values. So Python list only contains one value divided by comma. Dictionaries contain two values. So lists are more useful to store data where you're not interested to keep pairs of data. So in this case, this is about the PIN codes of employees. And so it contains the name of the employee and the employee PIN code tied to the name. Similarly, you have Joe with another PIN code and Jack. And you see that we use curly brackets to create a dictionary. So let me copy this dictionary in here. And you'll see that indexing, number indexing doesn't work for dictionaries. It actually says key error 0, which means that there is no key named 0 in the dictionary. But if you did pins Mike, that will give you the value for the key Mike. And by the way, the type of the value of Mike is an integer. So 1, 2, 3, 4 is an integer. Now, if you want to know all the keys of a dictionary, you would refer to the dictionary, so to the variable that is holding the dictionary, and then to the keys method. This method doesn't need any arguments, so you just don't pass anything inside the brackets. And you see that you get this Mike, Joe, and Jack. These are the keys. If you want the values, you get these values here. Alright, that's about dictionaries. In the next lecture, I'm going to explain this line in here. See you there. Great, let me exit the Python session and execute the program basics.py. So the way the program is executing is we're storing this list in the address variable, we're storing this dictionary in the pins variable, we're printing out the first and the second item of the list using the print function, and then the program executes this line. Now in this line we are storing the output of the int function in the pin variable. So functions, they produce some output, and when you create a variable and you assign the function in that variable, basically you are assigning the output of the function in that variable. The output of the int function in this case is dependent on this argument. So the argument of the int function is yet another function. So it's quite tricky, a little bit. And so this other function is the input function. And the input function has this input as this argument itself. And so what an input function does is it basically suspends the program and it asks the user to enter some input. And once the user enters some input, let's say 10, the program goes to the next lines. In this case, it didn't find a correct pin code because 10 is not in any of these pin codes, so it interrupts. But yeah, the idea is that the program will resume when you enter an input and press enter. Now let's look at another example of the input function. Let's create a script with nano. Let's call this try input.py. Let's make a program that calculates the square of a number, or in other words, it calculates the power of 2 for a number. And let's create a variable user input and use the input function that we're talking about and ask the user to enter a number. That has to be in quotes and in round brackets. And so let's say the user enters 10 and you want to calculate the power of 2 for 10. That would be, say you want to print that out, user input in the power of 2. Let's see what we get. Y, enter. Python 3, try input, enter a number 10, and we get an error. This is saying type error unsupported operand type. So this is saying that basically the number you are using is a string, it's not an integer. And that is because the input function always produces a string output. So even when you pass a number, even when the user passes a number like 10, this function will convert it to the string 10, not number 10. In that case, you want to convert that string into an integer or a float, if you like. Let's keep it an integer for now. If you try this now, enter 10, you'll get 100, which is the square of 10. And so, you could also do this another way. You can use the int function directly at source. So you can put it here and directly, immediately convert the user input into an integer. That would work the same. It doesn't work. I did something wrong there for sure. Yeah, I did. Basically, I am calculating the power of 2 for the print function. This has to be like that. Execute 10, and you get 100 this time. So as you see now, this here is the same as this one in here. And the reason why we're converting this to an integer is because the user is passing a pin code like 1, 2, 3, 4, but in the dictionary you see that these are not in quotes, the pin codes. These are in integers. So therefore we need to convert them to integers, because otherwise when we compare them later here in the code, like this, for example, let's say you compare 1, 2, 3, 4 to 1, 2, 3, 4, and you get false because this is not the same as this. If you do 1, 2, 3, 4, compare it with 1, 2, 3, 4, you get true. So this is an equal operator. It compares, it checks if two objects are the same or not. You also have the other comparison operators for numbers, like that, checking which number is greater. So as simple as that. And that's how the input function works, and I'll talk to you in the next lecture. Hello, and here we are with a very important lecture. It's about conditionals. And we're progressing with our program now. We covered these 4 lines. Now we're stepping with all this block of code in here. and that what remains is this function. So in this lecture we're going to cover this. All these lines here are part of a Python conditional block. And a Python conditional block, what it does is it checks if a condition is true. This is a condition. And if the condition is true, it executes something. Otherwise, so if the condition is not true, it executes something else. So either these lines will be executed or these. It cannot happen that you get both these and this executed. So either this or this. What are we checking in our example? Well, we are checking the pin code submitted by the user via this function here. Let's say the user submits 1, 2, 3, 4. So we check if 1, 2, 3, 4 is in the values of the pins dictionary. So pins.values will give you this object, which is a special object. It's like a list. It's not exactly a list, but it behaves like a list. So it has several items, and it's like a sub-component of the dictionary object. And so basically, this line here is like doing, let's say, if the user submits 1, 2, 3, 4, you say pin in pins values, and you get true. So this pin is in the pins.values. If the pin was something different, you'd get false. So in other words, when this evaluates to true, these lines are executed. When this here evaluates to false, these lines are executed. I can show you this with another example. So if true, print yes, else print no, and you get yes. Because true is basically always true. So true is always true. This is a bit difficult to understand in the beginning, but if you don't understand it, you can try this other thing. So if 2 is greater than 1, print yes, else print no. Sorry. And so you see that you got yes, because 2 actually is greater than 1, and this expression is equal to true. So it's the same, doing 2 greater than 1 is exactly the same as doing true. And that's the idea. Now, something you should understand here is that we use these 4 spaces here. Let me clear this and try again. So when you do, let's say if 1 is equal to 1, and you use the colon, that's the syntax, and then when you go down here, you'd use 1, 2, 3, 4 spaces. And then you write the action that you want to perform, like printing something out, maybe. And else has to be within the same indentation level with if. And use the colon, 4 spaces, print no, like that. And you can also use 1 space if you like, so it has to be at least 1 space under if. But it's recommended to use 4 spaces because this way the code is more readable, so it is more distinguishable that the print function this actually is the action that is part of this conditional. And actually indentation is something special to Python, because other programming languages, they would use some characters to denote the ends of a line and to denote that the next line is dependent on the previous line. But in Python, you do this indentation. So let me exit this and execute basics.py. So our program, flat floor street 18, enter your pin 1234. So what happens at this point is, once you enter the pin, this number 1234 will be stored in the pin variable. So at this point, the script is at this point now, and it goes to the next line, because I told you that Python executes a script line by line from top to bottom. It goes to the next line and it reads all these lines, but when you have this def keyword, nothing happens. So this is a custom function that we'll cover later. But custom functions, when you define a function, you just define the function, you just define the blueprints, but you don't execute anything. Later you'll see that how we can execute this function, but for now Python just records these lines in the memory, but it doesn't do anything. It's like defining the code for the print function, so defining what the print function can do. So it accesses a command line and it sends some data into the computer command line. You could write those lines in here under the def keyword, but that would be just the definition of a print function. You are not calling the print function yet. Well, the print function is defined in some other files that you have installed in your computer, in this case in this Linux servers, and so the definition of the print function is there in the installed files, but it could have also been in here. So Python skips this, and then it goes to the conditional, and it checks if pin, which is 1234 at this point, so if 1234 in the values, in these values, so in is an operator which checks if a value is contained inside a sequence, such as this one in here. So a sequence can be values of a dictionary, can be a list, and so on. And in this case, 1234 is in the values, therefore these two lines will be executed. And so this line is executed now. Fruit, input, enter fruit. And as you know, the input function suspends the program again. So we have another input function in here, and we are being asked to enter a fruit. Now, if we enter the fruit, like orange, we get that fruit is in the list. Why do we get that? Well, that's because this line was executed. And what this line does is, now this line is calling this function to be executed. So here we define the function, but here we are calling the function. But you don't have to worry about how this got printed out, how the function works, because I'm going to explain that later. For now, let's just focus on the conditional block. Let me execute the program again, and this time I'm going to input a pin code that doesn't exist, that is not in the dictionary, 000. And in this case, you see that we got incorrect pin, which is printed out by this function. So this was evaluated to false, therefore we got this printed out. We got this other line printed out. This info can be accessed only by this one here. And then we have this thing in here, which is a for loop, but we're going to cover that later. And yeah, this is about conditionals. In the next lecture, I'm going to tell you something more about conditionals, and then I'm going to explain custom functions, such as this one in here. Talk to you later. Congratulations! If you have followed the course so far, that means you now know Python basics and you are able to build simple programs. If there are still things that you feel unsure about, that's nothing to worry about, because we're going to use over and over and over again all the fundamentals while we build advanced programs throughout the rest of the course. So you're going to see how strings and lists and dictionaries and functions and loops, conditionals and other core functionalities are used in real-world programs. Practice makes perfect. Now, in this section, you're going to learn some advanced code in Python, and specifically you're going to learn things like Python libraries and working with dates and times, advanced string manipulation, iterating multiple lists and handling files efficiently, looping based on a condition, etc. And from now on, I'm going to use Python installed on my local computer instead of using Python anywhere, which I've been doing till now. The reason for this is that in the next sections, some of the applications that we are going to build, the real applications that we are going to build, are programs that have a graphical user interface. So we're going to build desktop graphical user interfaces, and as you know, Python Anywhere only gives you access to its command line interface, which is this one in here. You don't have a way to access the Python Anywhere computer's graphical interface. And there are also web applications that we are going to build, and it's good to build a web application locally first on your computer, and then you can upload it to a web server, such as Python Anywhere or Heroku, etc., so that the public can view your web application, your website. And in addition, I think it's also important that you know how to use Python on your computer as well. But if you really like Python Anywhere, you can continue working with it, and if something cannot be done in Python Anywhere, you can simply copy your code in your local computer and continue there. That's perfectly fine too. And so if you don't have Python and a text editor on your computer already, in the next lecture you have instructions on how to install Python and the add-on text editor, which I'll use throughout the lectures. There are instructions for Windows, Mac and Linux. And yeah, thanks, and I'll talk to you in the next videos.
In this video, you will find the instructions of how to install Python and the Visual Studio Code IDE on your computer. Allow me to emphasize that Python and Visual Studio Code work the same way on all operating systems. The only thing that changes is the way you install them. That's why in this video you will find instructions on how to install Python and Visual Studio Code IDE on Windows, Mac and Linux operating systems. So if you are on Windows, go to minute 040 of this video. If you are on Mac, go to minute 247. And if you are on Linux, go to minute 420. How to install Python and the Visual Studio Code IDE on Windows. First, go to python.org, the official Python webpage, and then go to Downloads, and there you have a button there. That will ask you to save or run Python, so just run. And that will download the file and run it. So the installation started, and make sure to check this option at Python 3.7 to path, and then go to Install Now. And just wait for the installation process. Click Yes. Setup was successful, and close that window, and then search for your CMD program, which is the command line, the command prompt. Then type Python, and if you see these three arrows, that means Python was successfully installed. If the command Python doesn't work, then try py -3. And again see if you get those three arrows there to see if Python is installed. Now we can start typing code in here, Python code, but a better editor is the Visual Studio Code. So go to code.visualstudio.com and press that download for Windows button. Run. If you got a message that says this app cannot be installed on your PC, then please go back to that button and click it again. Sometimes it works the second time. And then go to I accept the agreement. I'd like to click all these options and go next, install. My installation was completed, so click on Finish, and that is Visual Studio Code. Here is how to install Python and the Visual Studio Code IDE on Mac computers. Go to python.org, the official Python website, and go to Downloads and click there on that big button. Once the package is downloaded, just follow the installation instructions. Agree, continue, install. And the installation has finished. To open Python, open your terminal app and then type in Python 3. If you see these 3 arrows, that means Python was already installed. Now you can use this terminal to code in Python. However, a better tool is Visual Studio Code IDE. So go to code.visualstudio.com and then go to Download for Mac. Click that button and the Visual Studio Code will be downloaded as a zip file. Click it to extract it, and then click the .app file that was inside the zip file, open, and that will open Visual Studio Code. That's how to install Python and Visual Studio Code on Mac. Here is how to install Python and the Visual Studio Code IDE on computers running on Linux operating systems. Look for your terminal program, open it, and run sudo apt-get install Python 3. So we are using Python 3 in this course. Execute that, and if you get this message, as I did, saying that Python 3 is already the newest version, that means Python is installed in your computer. That could be either because you installed it before and you maybe don't remember it, or Python was already installed by default on your Linux operating system, which is the case with new Linux systems. To check if Python is working, type Python 3. So we got the correct result, that means Python is working fine. So you can program from a terminal, but that's not the best way to do it. So the best way to do it is to use an IDE, where you can write the code in a text editor and you have features to debug your code and have syntax highlighting, etc. A good IDE is Visual Studio Code, so go to code.visualstudio.com and then find the correct extension for your system. For me, I would get the dep package. So click that button and click on Save File to download the .deb file. Then go to your downloads and just click on the deb file. Then on the package installer, just click on Install Package button. And wait for the installation to complete. My installation was completed, so I'll just close this window and look for VS, so for Visual Studio Code. And that is Visual Studio Code IDE.
Hi again. In this lecture you're going to learn the while loop. You already learned the for loop. You saw that the for loop was iterating through a list, so or a tuple or a dictionary, whatever it is, so through a sequence, and was doing something on that sequence. Now, the difference between the for loop and the while loop is that the for loop will run as far as there are still items in the list. So the for loop will run until the moment that the list is consumed. Now the while loop is different. The while loop will run until a condition is true. So for example, let's say until x is greater than a number, the loop will do this thing here, do something. So let me go ahead and do an example. That's the main difference between the for loop and the while loop. The for loop runs based on a sequence, the while loop runs based on a condition. Let's say while x is smaller than 3, print smaller. What is x, by the way? Well, x, we have to define it here in here, otherwise we'll get a name error. Python will say that you haven't defined this variable. So let's put a value, an initial value of 0. Then, while the loop runs, the loop will iterate, so it will run several times. And then we want to find a way to change x as the loop executes. So let's say x will be increased by 1 in each iteration of the loop. So let me try this. And this is what you get. You get this string printed out 3 times. And this is what happened in the script. So Python executes a script starting from the first line and it goes down one line, one by one. In the first line, what we do is we assign 0 to x. So now we have a variable. And then the while loop checks if the value of that variable is less than 3. So in the first iteration, this will be evaluated to true, because 0 is actually less than 3. So 0 is less than 3, if you don't believe me. Yeah, the idea is that I wanted to show you that this actually is equal to true. So while true, these things will be executed. And therefore, print smaller will be executed when x is 0. And then x, we are redefining the variable here. So basically, we are saying that we're creating a new variable, which is called x. And this new variable will get the value of the existing variable x plus 1. So 0 plus 1. And we're redefining a value of 1 to x, because 0 plus 1 is 1. Now, when Python goes to this line, then it goes to the while loop again. If there were more lines in here, it doesn't go through those lines because the loop is still running, the condition is still true. So Python goes to this line again, and this time x is 1, so 1 is smaller than 3, yes, print this again. Then x is redefined, so x is equal to 1 plus 1, so 2. Go there again, 2 is smaller than 3, print smaller again, and then goes redefine again, x is 2 plus 1 is 3, goes to the while loop here, 3 is less than 3, no it's not. So what happens is that Python doesn't execute these lines anymore, but it goes to execute the next line. And since there are no more lines, the program ends. So you see that you don't get any more output in here. That's the idea. I still have one more example to show you in the next lecture about while loops, and then we move on with other concepts. So see you in the next lecture. Hi, welcome again. In this lecture, I'm going to show you another example with while loops. Now I want to create another file here. It's a new file. Let me call this password check.py. What I'm going to do is I'm going to build a program that asks the user to enter a password. And the program runs until the user enters the correct password. And the correct password, we're going to store a string, a password inside our Python script. So how to do that? We will do that using the while loop. So first we need to define a correct password. Let's say Python 123. Once we have that, we want to ask the user to submit a password. How do we do that? Well, using the input function, enter password like that, and then we have the while loop. So in this case, basically we want to run the while loop as long as the user is entering the wrong password, because we want to keep asking the user to enter a password, like enter a password, enter the correct password, you enter the wrong password, enter the correct password, and so on. So basically we want to check for the condition that the entered password is wrong. So how do you do that? Well, while correct password is different than password, because you know this will give us is A different to B Yes, true. So similarly here we're doing like is Python 1c3 different than pass. Yes, it's true. So this will be evaluated to true as long as the user enters the wrong password. So if the user enters a wrong password, what do we want to do? Well, we want to execute this code again. Let's enter another message here. Wrong password. Enter again. Like that. And if the user enters the correct password, then the loop will break. Because basically, the loop will break because this will be evaluated to false. Python 1, 2, 3. Yeah, I have it correct. Yes. So false. In that case, we may want to print out logged in outside the loop, because when the loop terminates, the next lines will be executed like that. Exit this. Enter passwords. Is it 1, 2, 3, 4, 5, 6? No, wrong password. Enter again. Is it this? No. Is it this then? Yes, logged in. So that's how you use the while loop to check for something, to ask the user for something over and over again. I hope this is clear, and if you have questions, ask them in the Q&A section. See you. Hey, in this lecture you're going to learn about string formatting in Python. So let me ask you a question. In our current program, what the program is doing is it's asking the user to enter a password, and then it checks if the password was correct. And then we print this logged in. How about asking the user to also submit their name, just to say, hey, John, you're logged in. How do we do that? Well, for that we need to use string formatting. So first of all, we would want to ask the user for their name and store the name in a variable. Input, enter name, like that. And then one way to do this now is like hi, and then name here, and then you are logged in. Let's see how this will work. John, Python 1, 2, 3. Hi John, you are logged in. Now this works fine, it displays the string fine here, but it's not the suggested way to do it. The correct way to do this would be to use string formatting operators, such as %s, you're logged in, and then here another percentage after the string, and then name. So the name of the variable, which is name in this case. If you run this, you see that you get the same output. This is also good if you're trying to store this in a variable like that, and then print out message the variable. So again, you see, hi John, you are logged in. This would be difficult to make if we had this version. Message like that. Save. Let me clear this. As you see now, things get a bit complicated. So this is printing out as a tuple. That's why we should use string formatting. Like again, %s there, percentage after outside the string, and then the name of the variable. This can also work for multiple values, like enter name. How about surname? Input, enter surname. And then here what you do is, so you want to say hi John Smith, a comma, you are logged in. To do that, you say %s, so there is a space between John and Smith and a comma. You are logged in, and then here you need to use brackets to surround your two variables, like that. Save. Sorry, I had another extra bracket. I thought this was the print function here, but no, it's a variable. Let me execute again. And so we get, hi Gene Smith, you are logged in. That's how you use string formatting in Python. And I'll talk to you later.
Now, when you install Python, what you do is you make available the Python built-in code. An example of this built-in code would be the print function. So let me open a command window here and call Python. So when you say print, you execute and everything works perfectly. So where did you get this print function from? Well, when you start a Python session, like here in the interactive shell, or when you run a script, a Python script, the session loads together with a bunch of built-in functions and methods. And this is one example, so the print function. Now, there are also commands that are not loaded when Python loads, and these are considered to be less frequently used by programmers. So it has been judged that it's not a good idea to load everything into memory when you load Python. So the solution here, the workaround, is that you can load these commands explicitly yourself when you need them. And to do that, you use the import keyword. So let's say you want to concatenate, so to merge a bunch of text files that you have in a directory, in a folder. So you want to merge the text in one single file. And what you need first is you need to create maybe a Python list where you have, as items, you have all the file paths that you want to concatenate. And to generate a list of file paths in the current directory, you need a module called OS. So you need to import OS, because if you just do os.list_dir, which is a function that lists the file paths, you'll get an error. It says a name OS is not defined. So what you do is you import OS, and that is successful if you don't get an error. And then os.list_dir, and yeah, you get an empty list because I have nothing in here at the moment. So I'm gonna create a file, sample1.txt, and now you get a list with this file name. So what you did is you access the list_dir method of the OS module, and you can see a list of available methods that you can apply to your OS module. So dir OS, and yeah, among them you'll find list_dir, which is here, so just here. And yeah, don't get scared about this entire code. You don't have to know this. I mean, I don't know most of them. I've just used only a few of them. When the need comes to do something, you just try to Google, and you'll have people who have had the same issue. So you'll get the answer in some forums like Stack Overflow, and you'll see what other people have used. And yeah, this is called introspection. So when you inspect your code, when you see information about the code, like we did here with the dir function. And yeah, OS is a module. We also have libraries and packages, which basically are the same thing, but I'll go through them one by one. So let's focus on module first. And a module is just a Python file, a .py file. So if you apply the file method with double underscore in front and on the back, and you'll get the path of the module. So you can see here it's the module name is OS, so the file name is os.py, and you can go ahead and locate that file now. I think it should be this one here. Yeah, here it is. So this is my Python installation, and you have a lib folder in there, and just inside that you have all the external modules that you can import in Python. So you can try any of them if you like import pickle, and if you don't get an error, that is successfully imported. And you can also ask for help, graphical to see what the module is about. So create portable serialized representations of Python objects. And this particular module is used for network programming. So if you're interested, you can look at that. And yeah, if you can open this file with any kind of editor. And yeah, this is quite scary. You don't have to understand this code. This will do the work on the background. But it's just good for your information to know what a module is. Alright. Now, there's also the concept of libraries. And libraries have usually more code, so people who build them, they just decided to write the code into different files instead of just one .py file. So you have a collection of .py files for libraries. However, the way you use libraries in Python is the same. So let me locate a library here. So we're still in the lib folder, and all these folders that you see now are libraries. For instance, SQLite 3. If you go ahead and say import SQLite 3, and that is successful, so you did the same thing as you did with modules. And if you look at SQLite 3, you'll see a bunch of Python files, as I said. And here you have files as well. You don't have to know this, but basically what happens is when you import a library, this init.py file is executed in Python, and this contains the code that loads all the available methods in Python. Now this particular one, what this does is it imports yet another file into Python, so a module SQLite 3 DB API 2. Which is this one here. So it refers to SQLite 3, the folder name, and then a dot, and then DB API 2, the name of the file, of the Python file that is imported. And then inside here you have other code, and so on. You don't have to know this. It's enough to understand the structure. And yeah, that's about libraries and modules. And these modules and libraries, they come with your Python installation by default. However, they don't do every possible thing that is out there. That's why third-party modules and libraries exist. And these are often referred to as packages. Now, these packages, they don't come with the default installation of Python. And the good reason for that is there are lots and lots of packages out there, and you don't want to get a heavy installation there on your computer by default. There are packages of biology and astronomy, web scraping, everything, and so there are things that you're not really interested. And yeah, the solution to that is you install these packages, and then you use them just as you do with modules and libraries. And the way to install them is you just open your terminal, so command line on Windows, terminal on a Mac and Linux. The directory doesn't matter, and all you do is you say pip install, let's install glob2. So this is a package, or you can refer to it as a third-party library, and you hear people referring to packages as the third-party libraries. And yeah, this installs glob2 for you. Now you can go ahead and access it in any Python session, glob2, and yep, you're done. Similarly, you can ask for help for that package, so help glob2, and yeah, you see what this is about. Sometimes though they don't say what they're about in the help file, so you'll have to search on the internet for glob2. And every package has its own page almost. So glob2, just like that, and yeah, you go here. So what this does is it captures patterns and supports recursive wildcards. Basically what this do is, you know, if you say glob2.glob, and yeah, you just need to pass a file path there. Sorry. And yeah, what this does is when you pass an asterisk there, it lists all the files in there. But if you want only the text files, you do want to say asterisk.txt, and it gives you every file that has a txt extension. So in this case, you have this particular file in that directory. This is useful over a list dir because, you know, if you want to only get access the txt files, and you'd want to do this because in a directory you may have lots of files. This allows you to access only a few of them. And yeah, now about pip. So you saw me use this pip package. Actually, pip is a library that comes installed with Python, and you can find it in the scripts folder. Pip, so pip.exe is for Windows. Pip is normally in the computer search path, which underlies that, you know, when you are in your terminal and you do pip, your computer knows where to get pip from, so it gets this pip.exe. And pip, then what pip does is it downloads the package, and once it downloads it, it installs it. So if you go up here, yeah, it says pip install glob2 and downloading and then installing the package. And then the package is there in your system, and you can use it as you do with modules and libraries. So to sum it up, modules are Python scripts that you can import into Python, and libraries are collections of Python scripts, and you can import libraries as well. And also packages are third-party libraries. So 3 different terms are there, but library, you can use the term library as a general term for anything that is imported in Python. You know, just for the sake of simplicity, people do this. So that's about this lecture, and you could even make it through without knowing this information that you got from this lecture. But it's good to understand these things, as you can also understand and be able to fix problems that you might get with modules and libraries or packages. So yeah, if some things look unclear to you, then just drop a question, and I'll talk to you in the next lecture.
Hi there. In this lecture, you're going to learn how to work with date and time objects in Python. So what do I mean by that, and why do you need to learn about date and time objects? Well, let's say you have a task like to calculate how many days and seconds have passed from year 1900, maybe, up to current time. Let's say at this very moment, 2018, and March, and this hour and this time of day. So it would be quite a difficult task to complete unless you use the specialized date-time library in Python. So there's a library in Python. Actually, it's a module. You can import it like this, or even better, you can do from datetime import datetime. So what I'm doing is I'm importing this object from this module. It happens that the module name and the object name happens to be the same in this case. If we didn't have this datetime object of the datetime module, the way you do this would be very complicated, because there are lots of variables there to calculate the days. You have different years, February with 29 days, February with 28, and so on. But this module, this object, this will take care of everything. So let me show you how would I calculate the difference. So I want the difference from now to year 900, maybe the last day, let's say the 31st of December 1900. And if you want to know how many days have passed until then, this is the answer. If you want to know the seconds as well, to be more accurate, this is the answer as well. So from the current date and time, which is this one here, for me at least, for you should be different. So from 2018, 2nd of March, this is the hour, this is the minute, these are the seconds, and these the microseconds. So from this date up to this date have passed this number of days and plus this number of seconds. This would be how would I solve this exercise. Now let me explain how this all works. So in the center of this all this thing is the datetime object. So this is a special object, just like you have list and other things. This is a special object which has its own methods, which are these ones in here. So you can create such an object for the current date and time, which is this one in here. So now I have just stored this datetime object in the now variable. Every time I call now, I get the same object now with this date, because this was registered at the time that I executed this datetime.now. So if I do datetime.now again, every time I execute this now, I'll get different seconds, as you see, 44, 47, 48, 49. And the other way to create a datetime object was by, let's say, then you call the datetime object, and then this expects arguments from you. So let's say 1912, that's the month, that's the day. You can also pass hours, like 20, and minutes, like 12, and also seconds, like that, and even microseconds if you like. So then is also a datetime object, just like now. And then minus now give you another object which is actually a time delta. It's not a datetime, but it's still part of the datetime module, as you see here. So this gives you the days and the seconds. Let me clear the terminal with Ctrl L. So we had two ways to create this datetime object, and through this. Now there is another way to do that, to create a datetime object. Let's call this whenever, and you'd call the datetime object and then strp_time. And here you need like some string, so you can create a datetime object from a string like that. Let's say the month and the year. And now you have to specify through some special strings which start with percentage and y for the year. So you have to tell Python what this string here means, because Python doesn't know what you have written. So you have to specify its format. Percentage m, small m, so lowercase m for the month. And the other one was percentage d for day. Execute that whenever, and you see the datetime object. Again, just like now and then, this is also a datetime object, and you can perform datetime operations with that, like doing the difference. Of course, you could have different formats in here, like that maybe. And maybe you have hours as well, like 20, and minutes, like 59. So you have to specify those two. So this has to reflect the format of your string. Year, month, day. For hours, you use percentage capital H, and for minutes, you use percentage capital M. Whenever, and you see the year, the month, the day, the hour, and the minutes. And lastly, you can also convert a datetime object into a string using the strftime method, which means a string from time. And here we want to specify the format of the string. So how do you want it to be? Maybe you just want the year, like that, out of that datetime object. So that will give you the year. Or maybe you want also the month and the day, and maybe you want a space, the hour, or maybe a colon, whatever you want, and minutes, like that. And see, you get the format of a string, just like you specified it in here. You can see other methods and properties that you can apply to a datetime object. You can do datetime like that. So you can see that you can get the month like that. You can get the year. You can get a day like that. So these are integers, by the way. And that's how you work with date times in Python. I hope you enjoyed this, and I'll talk to you later. Hey, welcome again. This will be a very short lecture, and in this lecture I'll show you how to iterate through multiple sequences at the same time. And what I mean by that is this. Let's say we have these two lists in here, A and B. List A has 3 strings and list B has 3 numbers. Now your task is to print out these 3 lines, where in each line you say something like A is 1, B is 2, and C is 3. That means you have to iterate through this list at the same time. How to do that? Well, to do that, you do, let's say for I and J, these are 2 variables. You need 2 variables because you are iterating through 2 lists. In zip A, B, these are the lists. And you use the zip function, which is a built-in Python function. We're not importing it from anywhere, so that's a built-in function. And then you do print, let's say %s, a string formatter is %s, %I and j. And this is what you get. If you don't understand that, this is a simple version of this. So basically you are printing out, in the first iteration, you're printing out the first item of A and B of these 2 lists and so on. This may become handy sometimes, and actually we're going to have a use of this in one of our real-world applications, where we access some coordinates from some CSV, some Excel files. So keep this zip function in mind, and I'll talk to you later. Hello, this lecture will be about the with context manager. What this is it's a useful tool to use for file handling. You already learn how to create a file and write something in that file with Python, like example.txt. In write mode, you see example.txt was created when I executed this line, and then you did my file write something there, just like that, and then you had to close the file for the changes to take place in the txt file. Now, the recommended way to actually create a file, to handle a file, let me delete this. The recommended way is to use the with context manager. With context manager is like that. With open example.txt in write mode as my file, so that's the variable, my file write. So here you write all the operations that you want to perform to the file that you have opened. So we want to write something. Now if I execute this, you'll see that example.txt will be displayed in this directory tree in here. Execute. You have to execute one more time here in the interactive shell to tell Python that you are about to end this block, because you see we had these 4 white spaces there. So execute one more time. You see example.txt is created successfully. So why is this with statement more preferred than the standard way, than this one here? Well, that's because you see that you don't have to write myfile.close with this block of code here, because the with statement will take care of closing the file for you. That means you have less code. That's one benefit. The other benefit is that if your script breaks, let's say you are handling the file, and you have this write method here, and then between the write method and the close method you have some other code, and this code breaks for one or the other reason. And what happens in that case is that your file will remain open by Python. So that may cause problems, because the myfile.close method was not executed. But with the with method, you have a block of code here. So what happens is that if something in the block of code breaks, the with statement will take care to close the file for you, so that the file doesn't remain open. That's the idea. So always use this block of code when handling files, and write everything indented that has to do with accessing the file object. That's it. See you.